Separable differential equations. Objectives. Find this lesson show 2. Recognize a separable differential equation. Separate the variables given a separable differential equation. Solve a separable differential equation with or without initial condition. And understand the application to differential equations in a variety of settings. So first, let's go over a couple examples. Separable differential equations. The differential equation has the form dy dx equals f of x times g of y, so that it can be rewritten in the form. So you can separate the x's and the y's. So for example, if I give you dy dx equals, let's say, y squared x plus 1, I can separate this one. I can multiply dx to both sides, and I can divide the y squared to both sides. It's a mess, I'm sorry, but you essentially get 1 over y squared dy equals x plus 1 dx. Right, that's a separable differential equation. So I have all the y's on one side, I have all the x's on the other side. If I give you this instead, this I can't separate. I can multiply both sides by dx. But that 2y, I'm never going to be able to move over there without how to distribute the dx. It's like not going to happen. So this is not a separable differential equation. This is a separable differential equation. I guess I started off here. So that's an example. Explicit, implicit, and explicit solution is any solution that's again the form of y equals f of x. In other words, the only place the y shows up is on one side of the equation and only raised to the first power. You just have a y equals when you're done. And the implicit solution is any solution that is in that form. So let's talk about how you're going to solve this. I kind of showed already. First, you separate the variables by gathering the same variables on opposite sides of the equal sign so that the equation looks something like this, like I did up there. And then when we get to that part, we're going to integrate both sides. So we're going to separate, then we're going to integrate respect to the appropriate variable. Although both sides have an indefinite integral, we use a general constant, so we have a plus c on. You can't technically have plus c on both sides, but we move it. In our head, we move it over. So we just put it on one side. Because like if you had on a y plus c equals x squared plus c, that's kind of pointless. Because this could have been 2, this could be 5. We're just going to subtract the 2 from both sides. So anytime we do this, we're going to say this side has a plus c. Because it doesn't really matter if they both have plus c, we just move it over. So that's kind of the idea. So let's put plus c on one side. In most cases, this is the x or the t variable. If provided, use the initial condition to solve for c. So after we do that, we're going to plug our points in to find c. Then we rewrite it with our c plugged back in. So that's the process. Separate, integrate, put a plus c. Don't forget the plus c. That's what this side's about. Then we solve for plus c, or solve for c, and then we substitute back in. So that's the system. Let's do it. So this first one here. Example, solve dy dx is equal to 6xy squared, given y1 is equal to 1 over 9. So right, first we're going to separate. We're going to add the dx to both sides. So I get this. Multiply both sides by dx. Then we're going to divide by y squared. Again, I show way more work. You wouldn't have to show all that work yet. You'd skip just from the beginning to here. Alright, so I separated them. Now we're going to integrate. To integrate this side, that's easy. Just add 1 to the power, divide by any power. And I get 3x squared. We generally put a plus c on this side. This side's a little more tough, right? It's on the bottom, so I have to move it up. So I essentially get this. And then we add 1 to the power, divide by any power. So I get negative y to the negative 1. So that's what I got. So I made it y to negative 2, added 1 to the power by any power. Let me rewrite this a little bit so you could use it a little better. So I get this. So that's my equation. Now I want to solve for my c. So I'm going to plug the 1 over 9 in. So remember what this says is when I plug in, when we substitute in 1 for x, I'm going to get 1 over 9 for my y. So I'm going to have this. Negative 1 over 1 over 9 equals 3 times 1 squared plus c. Remember the same trick that works here? 1 over 9, just the 9 moves to the top, so I actually just get negative 9 equals 3, and 1 squared is 1, plus c. So negative 12 equals c. Then we're going to rewrite it. So I'm going to get negative 1 over y equals 3x squared minus 12. But we are not done. Remember the last part was get y by itself. I didn't read that part. I should have. Get y by itself. We all want to get y by itself. What am I looking for? We want an explicit solution. That's what I'm looking for. Explicit solution. So we want to get the y by itself. So this is not good. So what do we always do? Multiply both sides by y. I get -1 equals 3x squared minus 12 times y. Then divide by 3x squared minus 12. And we get y equals -1 over 3x squared minus 12. And that is the solution in its final form. Right, it's a little annoying at the end, but you do have to get y by itself at the end. So just do a little bit of algebra. You should be fine. Next one. So we want to solve dy dx equals x to the 4th, y minus 2, given our initial condition of y0 equals 0. So right, step 1, let's separate them. So multiply both sides by dx, and also divide both sides by y minus 2. So I should get this. Right, so again, it says multiply both sides by dx, divide both sides by y minus 2. Next, after that, we integrate both sides. Again, left side's easy. So I get x to the 5th over 5 plus c, we put the plus c on the right side. Then we gotta integrate this side. It's a little tougher. I'm doing this side over here. Notice how the bottom has no power, so this is a natural log. That'll be natural log. You can do a u sub, but let's do a reverse chain rule because it's linear terms. So it's classic reverse chain rule. So we're gonna integrate the outside, which is just natural log. Do the inside alone. Times by 1 over derivative of the inside. Derivative of this is just 1. And then plus c normally, but again, we're not going to deal with that because we have it on the other side. So that's my integral. So that's where I'm at right now. Right, we did everything. Now all we got to do is find our c. So right, so we want to find our c. So we're going to use our initial condition. So when I sub in 0, it equals 0. So I have natural log of 0 minus 2 equals 0 plus c. So natural log of absolute value of -2 equals c. So natural log of 2, that's why absolute value comes in handy. Actually, just write natural log of 2. 2 is a positive number by itself. So that's why absolute value comes in handy, right? That's why we need it when we do our thing. So you can't have a natural log of a negative number. So now we found our c. So next thing, plug it back in. So now my equation, we're going to go back to here and we're going to sub in our c. So now my equation is this. Right, and we're almost done. Last step is get the y by itself. Again, it's just a process. First step, separate it. Now, if you're taking an AP exam, that's worth the point of separating it. Second step, attempting to integrate, worth another point, integrating this guy. Third step, finding your c, worth another point. So we're already like 4 out of 6 points in just by getting to here. If we want our last goal point, we have to get y by itself correctly. Now this one's going to be a little more work because I have this natural log here. So first thing to do is get rid of the natural log. So remember how to do that? We take the e of both sides. So on this side, e natural log would cancel out. I get natural log absolute value of y minus 2 equals e to all this mess. And I'm still not done. I got to get the y by itself. Right now it's still an absolute value. So we got to break up the absolute value. Remember how do we do this from row 1? You do a positive version. You just keep it the same. And then we do a negative version where we negate the right hand side. So it'll be like this. This will be a negative version of that. There we go. So it's just like if you were solving absolute value of x equals 3. You should have got x equals 3, and then x equals -3. Right? That's why it could be a positive negative version of this. So that's what's going on here. This could be a positive and a negative version of this. So write that. Each side solve for y. So I have y equals, let's add the 2 over. E to the x to the 5th over 5 plus natural log of 2 plus 2. Same thing here. Y equals negative e to x to the 5th, positive, plus natural log of 2 plus 2. Now you know what you're saying. So we have 2 answers? No. We actually have only 1 answer. One of these is not true. It's not correct. So how do we tell which one's not correct? We plug in our initial condition again. See which one holds true. So if I plug in 0, 0. So let's try it here first. If I plug 0 in for x, and I plug in for there, I'm going to get 0 equals e to 0 plus natural log of 2 plus 2. E and natural log cancel out, so I just get 2 plus 2. So 0 equals 4, which is not correct. So this is not my answer. which makes this the answer, as long as I did it correctly, right? So we want to check your work. Let's plug in 0. Again, E and natural cancel out, and I just get negative, oops, I get negative 2 plus 2, which would be 0. So this is my answer. I know, a lot of work there at the end, but that's just the algebra part of it. All of this is part of the problem, right? So it's just take it step by step. It's just a process, right? Step 1, separate it. As you separate, step 2, just integrate both sides. If you do that correctly, you have a plus C on one side. So what do you do after that? Plug your initial condition in to find your C. So plug in 0, 0. I got C equals natural log 2. Once you find your C, go back and plug it into your equation. So I got that right here in green. Once I do that, then it's just algebra. Let's get the y by itself. So in this case, I had to take the e of both sides. That left me with the absolute value. So I had to separate it, one positive, one negative, and then had to figure out which one was the real answer. A lot of algebra, I know. Next one. That should say example. Anyway, step 1, separate them. So right, we're going to multiply both sides by dx, and then we'll probably multiply both sides by dy. Or if you want, you can think about it as cross multiplying. So I get this. Step 1, so what's the point? Step 2, integrate, another point. Right side's easy again, so negative x squared plus c. Left side's pretty easy this time too though. So I get this. That's an ugly y squared over 2, by the way. Slightly better. And then step 3, solve for c. Plug in 1 equals negative 1. So when I sub in 1 for my x, it should equal negative 1 for my y. Negative 1 squared is just 1. Minus 1 plus c. Add the 1 to both sides. I get 3 halves, denominator, equals c. Right, and then once we find our c, we sub it back into our equation. So we should have this. Right, and then we're almost done. All I gotta do now is get the y by itself. So if I was in this case, I would multiply everything by 2 to get rid of that 1 half. So I get y squared equals both of them. Negative 2x squared plus 3, and then we square root it. Don't forget, when you square root, you should get, most like the absolute value, you should get 2 answers. You should get the positive version of it, or you should get the negative version of it. How we know which one's real? Same idea as before. Plug this in. Here's a little shortcut in this one though. Right, we're plugging 1 in, and we should get a negative 1. We have absolute value here. Okay, so we have a square root here. No matter what, since we're taking a square root, this should be positive. So if you only can plug them in, or you can just look at it, think about it logically. Wait. This is going to be positive. Positive times a positive. So it's going to be a positive. On this side, it has to be a positive. Positive times a negative is be a negative. I need the negative. So this is the correct answer. Right, that's the only one that's going to give me a negative answer, which is what I should get on this one. Again, if you're not sure, just plug it in and see what you get. It's actually not, it's probably really easy also. Plug in 1, I get negative 2 plus 3, which is 1. Square root of 1 is 1. 1 times negative 1 is negative 1. Easy enough. Next one, you thought how to run the other one was ugly. Wait till you see this one. So first, let's talk about what the y prime means. Remember, y prime just means dy dx. So dy dx, right there. So first let's do that so we understand they're all in the same spot. So that's all y prime means, it's dy dx. So next, we have to move this over. So we get dy dx equals negative e to the x plus y. Alright, let's subtract this from both sides. Next, we got to work on separating, right? So let's multiply the dx to both sides. So I'm going to get dy equals negative e to the x plus y dx. Now, as you're saying, how am I going to separate that x and that y? Right? If it was just x plus y, it was not possible. But there's an e here. So we use some algebra tricks to help us here. So let's review that a little quick. If I gave you guys x squared times x to the 5th, I think we all agree that's x2 plus 5 or x7. But I care about this right here. Right, so the general rule is x to the power of a times x to the power of b is equal to x to the power of a plus b. That's what we're going to use for advantage. We're going to go here, we're going to go backwards. I have x to the a times x to the x plus e to the x plus y. So I can separate this as in negative e to the x times e to the y dy. Might ask, why is it not negative e? Because that make two negatives make a positive, so where does that negative go? So it's kind of like the parenthesis around these two guys, so it breaks up to like this. That's why it looks like that. Anyway, now let's separate it. Oops, sorry, this has been dx. So I'm going to divide by e to the y. I always like putting 1 over e to the y. This helps me visualize it better. So I get this. So now it's separated. There's our point. Next point, just integrate this. Right, so I integrate both sides. This side's easy, always. Right hand side's easier. What a surprise. Like that. Left hand side, I gotta move that up first. So this is gonna be the integral of e to negative y. That is a reverse chain rule. So it's gonna be integrate the outside, e to negative y, times 1 over the derivative of the integral of the inside. The derivative of that is negative 1. Again, no plus c because we already put the plus c on that side. So if we simplify this, we get this. Something to that effect. Okay, so next step, normally it's to find our plus c. But in this case, they didn't actually give us an initial condition. So we gotta do an implicit formula because we have to solve for y with the plus c in it. So let's rewrite it. Give myself some space here. First thing, so when I get y by itself, let's get rid of that negative. So by negative 1. So I get e to negative y equals e to the x. Now, I'm going to put negative c here. You could easily put plus c because this is a constant. I'm not sure why I want to do that. We'll put plus c. It's just a constant. Constant could be, c could be anything. So it could be negative, it could be positive. It does not matter. So, you know, you can put negative c, plus c is also valid. That's like plus is better. Okay, now let's get that e by itself, right? So next will be the natural log of both sides. These, again, the y goes to the negative y goes to the front, those cancel out, so I get this. The natural log you do not cancel out here because it is plus c, so you can't just cancel one side out, it has to be both things. And then let's get rid of that negative 1. So I get y equals negative natural log of e to the x plus c. And that's the answer. Okay, let's do an AP type question. 5. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time equals 0, when the bird is first weighed, it weighs 20 grams. That's our initial value right there. If b of t is the weight of the bird in grams at time t days after its first weight, then db dt equals 1 over 5 times parentheses 100 minus b. Let y b t be the solution to the differential equation above, which with the initial condition b of 0 equals 20. So this is our initial condition. They also told us up there. This right here, keep in mind what this is. We're taking a derivative of, this is derivative b of t, which is the weight. So this is a rate. This is weight over time. So grams per day. Right? This is grams. This is time, day. So grams per day. It helps if it actually looks like a G. There we go. So again, keep in mind it's a rate. So this is the first question. Is a bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. So it wants to know, how's it gaining weight? So that's a rate. That's about the rate. Is the rate faster at 40 or at 70? Well, let's plug it in. All right, these are grams. These are my B. So we're just gonna plug each one in for my equation right there. So let's do dB dt at 40. So I'm plug in 40, 150, 100 minus 40. That's going to be 1/5, 60, 12 grams per day. So that's how much it gains weight. That's how fast it's gaining weight when it's at 40 grams. So let's do the same thing for 70 grams. So do dB dt when the t equals 70. So that's going to be 1/5, 100 minus 70. So it's 1/5 times 30. So that is 6 grams per day. So at 70, it's only gaining 6 grams per day. So it's gaining weight faster when it's 40 grams. That's 12 grams per minute. So that'll be your answer. It'll be like 40 grams. It's gaining weight faster. We got to make a sentence. At 40 grams because the derivative dB dt at t equals 40 is greater than dB dt at t equals 70. So that'll be your answer. Let's making a sentence out of the work you did. Find the second derivative of b with respect to t in terms of b. Use the second derivative to explain why the graph of b cannot resemble the following graph. So first, it wants to find the second derivative. So right, we're just going to take a derivative again. To help us out, let's just simplify this first. So let's write db dt equals distribute, so 20 minus 1/5 b. Let's take a derivative of both sides. So db squared dt, derivative of 20 goes away. Derivative of this is just 1/5 b, so it's 1/5 b, but the wrong variable, so db dt. So I get this. That's what my second derivative equals. But if you remember, you cannot leave db dt like this. It's never okay to do that. You gotta exchange this. You gotta substitute it for what it equals, which is this guy. So I'm gonna get negative 1/5 of 1/5 of 100 minus b. I could leave it like that. If I wanted to simplify it, that would just give me, let's multiply those to negative 1/25, 100 minus b. Okay, so that's my second derivative. Now let's answer this part of the question. Explain why the graph of b cannot resemble the following graph. So keep in mind, we're doing a second derivative. So what does the second derivative tell us? It has to do with concavity. If it's positive, it's concave up. If it's negative, it's concave down. Look at our value here. We have a negative concavity. We have 100 minus b. B at most is going to be what, 70, 80 grams. So this is always going to be positive times that to be negative. So this is negative. So our second derivative, db dt, is less than 0. So this graph must be concave down. Which this graph is not. The given graph is concave up right here and then concave down. So that's why this graph cannot resemble it, because this tells us it should be concave down the whole way. We have a little mix up here, which the given graph is not. So that's our answer to B. Now let's finish it off by doing C. Use the separation of variables to find y equals b of t, the particular solution to the differential equation with the initial condition b0 equals 20. So they want us to separate that original equation they gave us, which was db dt equals 1/5 100 minus b. So they want us to separate this, and then use this given value to find our c. So let's do it, right? So remember, step 1, separate the variables. So put dt on both sides. So I'm going to get something like this. db equals 1/5 100 minus b dt. Now I need to move this b to the other side. Now, easiest way to do it is just divide. Divide this to both sides. So I'm going to get, so it looks like this. 1/100 minus b db equals 1/5 dt. So now they're separated. Point. Next up, let's integrate it. Other point. Now you get a point just for like attempting to integrate it. So this side's easy as always. Just add the variable to it. So 1/5 t plus c. This side's a little more complicated. So let me write that over here so you can go over it. So it's integral of 1/1 minus b db. Notice there is no power on the bottom, so it is a natural log. I'm going to do a reverse chain rule. So it's natural log of 100 minus b. Don't forget the last part of the reverse chain rule. 1 over derivative of the inside. Derivative of this guy is -1. So this is 1 over -1. Yeah, that's an ugly integral. So I get negative natural log of 100 minus b. So I get this separated. Next, find our c. So for another point, let's plug this guy in there. So when I plug in 0, it should equal 20. So I get negative natural log of 80 equals c. So negative natural log of 80 is our c. So now let's rewrite it for another point. So I get negative natural log of 100. So So rewrite this. So plugging our C in. Minus B equals 1/5 t minus natural log of 80. Now to the final point, we gotta get B by itself. It's a natural log, so it's never pretty. You gotta get rid of the negative first. So let's divide everything by -1. So I get natural log of 100 minus B equals -1/5 t plus natural log of 80. Next, we gotta get rid of that natural log. So we'll take the e to both sides. So I get 100 minus b equals e to the -1/5 t plus natural log of 80. And then we have an absolute value. We did this one earlier, right? So there's the absolute value. We split it. One positive, one negative. Keep one exactly the same. And one, you negate the right-hand side. So you don't do anything to the absolute value part. You do it to the outside part. So e to the -1/5, negative e to the -1/5 t plus natural log of 80. Get b by itself. So we're going to subtract 100 and divide by -1. So it's going to look like this if all said and done. So, or let's say you could add b and subtract this. Works out either way. So I add b to both sides and subtract e from both sides. Alright, that's all I did there. I went plus b and then subtracted this. Same thing here, go plus b and plus that. So on this case, I'll get b equals 100 plus e to the -1/5 t plus natural log of 80. You get down here. Now I gotta figure out which one's the correct one. Now remember, what was our initial condition? When I plug in 0, I get 20. So when I plug in 0, I should get 20. So when I plug in 0, I want to get 20. So 20 when I plug in 0. Now, I know by looking at it which one it's going to be. Right? It's not going to be this one. E is a positive value. So if I do this, I can simplify it all the way down. I'm going to get e to the natural log of 80. Natural log of 80, that's just 80. So I'm going to get more than 20 here. I'm going to get 100 plus 80. That's all this is going to be. Right? Because this and this are going to cancel out. So it's not this one. And then on this one, if I did it, it would be 100 minus these would cancel out. So this is how that works. So that is my answer. B equals 100 minus e to the -1/5 t plus natural log of 80. Again, if you're not sure, just plug it in and see which one works. But it would be this one. Because you need to get 20. So I need 100 minus something. And it needs always positive. Anyway, that's this lesson.